So I'm going to take a mulligan on the that IOU and prove the following. So so I'm going to show that this evaluation map is continuous, which is the part that I owe you. So so we're going to let X be compact Hausdorff. Okay, and then we're going to let Y just be a topological space. So the claim is that the map from the mapping space, and if I take a point, so if I take a function and I take a point and I evaluate, right, and I'm going to send this to Y. Let me get another pen here. And so we take F, and I take F, and I take some X, and then I evaluate it. So this is the evaluation of F at X, so that this thing is continuous. Okay, so that's the lemma. It says that evaluation is continuous when we consider this compact open topology. And so the proof is what we do all the time. It's we show that the inverse image of an open set is open. So let V be a subset of Y, be open. Open. Okay, so we need to show, we will show that this thing is open. In particular, we'll show that, we show for each fx in F inverse of V, so there exists some mkv such that, well, this f of x, this pair fx, this is going to be contained in this mkv, and this is going to be contained in the inverse image of the evaluation map. All right? So that's what we want to do. All right. So we're going to use continuity of F and this compact Hausdorff hypothesis. So, okay. So by continuity of F, so this thing here, this is open. Okay, and so by the compact Hausdorffness of X, we have, so what do we get? So by this, so F inverse of E is an open set, right? And so this contains some K, which contains the interior of K, which contains X. So it's like we have these special open sets, right, that are these pre-compact sets. And they form a basis of open neighborhoods for X. So we can always take a neighborhood like this. And that's what's going to make this work. Okay? So, and so note that, F is an element of M KV by definition. Okay? And so what we'll do is we'll take our open set to be, oh, I guess it's not quite MKV, it's MKV cross something. That's where I was getting confused. Cross K. Okay, so we'll show that, okay, there's going to be some W here. Okay? So so let's try W being this set. MKV cross K interior. Okay? And so we just need to show, this is an open set, we just need to show that it's contained in here. So we'll take some random point, G I don't know, x, we don't want to use x, so gy, right, an element of w. Okay, so since g is in, so now what do we have? So g of y, so this is an element of g of k, interior, and this is a subset of g of k, but since g, so since g was an mkv, right, so this needs to be a subset of v, since g, right? Okay, and this proves that. So this proves that the evaluation map of W, right, is contained in V, or that W is contained in the inverse image of the evaluation map of V, and that proves that it's open. All right, so that's all I had to do. That's all we have to say about this. Okay, and that pretty much concludes what I want to say about compact Hausdorff, about the mapping space. I guess maybe I can clean some things up. And so let me just say some facts about the mapping space right now, and maybe get a fresh piece of paper.